Hey, greetings everyone. This is Dr. Selawi. In my previous videos, I gave a brief introduction to educational research, and I also talked about quantitative research in another video. In this one, I'm going to focus on descriptive and inferential statistics and give a brief introduction. So these are the topics that will be covered briefly. Descriptive statistics, inferential statistics, goal of statistical analysis, types of hypotheses, type 1 error, beta or probability of making a type 2 error. Okay, so these are the topics. And to start with, we will look at the mean in descriptive statistics. So the mean is basically the sum of all scores divided by the number of scores, often referred to as the average. It is a good measure of central tendency. Central tendency is simply the location of the middle in the distribution of your scores, as is shown on this chart on the right side. If for some reason you are using descriptive statistics in your research, you don't have to manually calculate each aspect of it. SPSS will do it for you by one simple click. It will generate your charts and everything. The mean. So the mean can be misleading because it can be greatly influenced by extreme scores, very high scores and very low scores. So for example, the average length of stay at an ESL program could be greatly influenced by one student that stays there for 2 years instead of 1 year or 1 semester. Extreme cases or values are called outliers. Sometimes the median may yield more information when your distribution contains outliers or is skewed, or in other words, it is not normally distributed. So what is the median? The median is the middle of a distribution. Half of the scores are above the median and half are below the median. How do I compute the median? If there is an odd number of numbers, the median in the data set that you are dealing with, the median is the middle number. For example, the median of 5, 8, and 11 is going to be 8. If there is an even number of numbers, the median is the number of the two middle numbers. It's the mean of the two middle numbers. So in this case, the median of the numbers 4, 8, 9, and 13 will be 8 plus 9 divided by 2, which gives you 8.5. The mode in descriptive statistics is the most frequently occurring score in a distribution. The mode is subject to sample fluctuations. It takes on different values at different samples. Mode is usually used with categorical, ordinal, or discrete data. Not recommended as the only measure of central tendency. Distributions can have more than one mode, and they can be called multimodal. Conclusion: examine your data all the time in order to determine what descriptive statistics is most appropriate before you move on. In a data set such as 555, 443, 221, the mode is 5 because it is the most frequently occurring score in this set. Okay? Inferential statistics are used to draw inferences about a population from a sample. Okay, so that's the goal of inferential statistics. Population means the group that the researcher wishes to study. That's your target population. The sample is a group of individuals that you would select from that population, and the sample should represent all characteristics of the target population. Okay. Inferential statistics generally require that the data come from a random sample. Okay. Now, random sampling, in this case, in a random sample, each person, object, or item of the population has an equal chance of being chosen. Okay, that's very important. Another important concept here when we deal with inferential statistics and in quantitative research is to establish what is known as the baseline equivalency. The baseline equivalence is when members of the treatment group or the experimental group are on average the same as members of the comparison group, those who did not participate in the study, so before the study began. Okay, so that's important concept to keep in mind as a strategy for you to design quality quantitative research studies. The goal of statistical analysis, as we mentioned, is to answer two basic questions. Is there a significant effect or association and or difference between the variables of interest? That is to say, can we reject the null hypothesis? If there is an effect or association or difference, how big is it? This leads us to the following example. So, assuming we are dealing with parametric data, meaning that the data is normally distributed, we will use an ANOVA test to compare the results to see if group differences are due to chance or are sufficient to reject the null hypothesis. We have to be careful in this case, especially when we are using ANOVA. An ANOVA test provides information on whether or not the groups differ, but it provides no information as to the location or source of the difference. The location or source of the difference. In other words, is group 1 significantly different from group 2 or 3? Or is group 2 significantly different from group 3? To determine the location of the difference when F value is significant, a post hoc analysis is used. Common post hoc analyses include Taki test, the Shafi test, Duncan multiple range test. So these are examples of post hoc analyses that are used to determine the location or source of the difference in the groups that you are studying. So by the way, parametric tests assume that the variable in question is from a normal distribution. So always in inferential statistics, you have to have normal distribution of your data. It has to be parametric. Normal distribution means that the data is not skewed in any direction. Non-parametric tests do not require the assumption of normality. So if you have abnormal data sets, you will have to be using non-parametric tests. If not, if you are not sure, you can run a quick test using SPSS to test the assumption of normality in this case. Null hypothesis. So I will give examples here from TESOL and second language acquisition. A null hypothesis is a hypothesis put forward to argue that a relationship or pattern does not exist. An example from TESOL and second language acquisition would be, in a randomized control trial, the control group and the treatment group have equal levels of second language proficiency at the end of the study. The null hypothesis is that group A and group B are equal. The null hypothesis is denoted or referred to as the following, with an H with a subscript 0 at the bottom. And by the way, in order for you to do that subscript, you will use control and plus sign on your keyboard as a shortcut. Whereas if you are using the superscript, you will have to go with control shift plus the plus sign. Anyway, other types of hypotheses we are dealing with, we covered the null hypothesis, and now we refer to the other type, which is the alternative hypothesis. This is the statement of what the study is set to establish. So for example, the alternative hypothesis here from an example from TESOL and second language acquisition, groups A and B have different levels of second language proficiency. So the null hypothesis will be true if the findings are insignificant. The null hypothesis will be false if the findings are significant. Alternative hypothesis is denoted or referred to as the following, with an H with a subscript 1 or an H with a subscript A. Okay? Alpha. Alpha level or significant level is the value that is determined by the researcher in order to reject or retain the null hypothesis. It is a predetermined value. It is not calculated. So it's a predetermined value that you decide on. In other words, if we select a value of 0.05, findings would be deemed statistically significant if they were found to be 0.05 or less. Now, what does this mean? Alpha indicates the probability that the null hypothesis will be rejected when it is true. In other words, the null hypothesis is wrongly rejected. This is called type 1 error or alpha error. This is what we refer to in statistics and in quantitative research as alpha error, is when the null hypothesis is wrongly rejected. Type 1 error, in this case, with an example, in a trial of a new ESL teaching method X, the null hypothesis might be that the new method X is no better than the current method Y. So the null hypothesis, denoted with an H and subscript 0 over here, there is no difference between method X and method Y. A type 1 error would occur if we concluded that the two methods produced different effects when there was no difference between them. Okay? So this is called type 1 error. All right? When we conclude that the two methods produced different effects when there was no difference between them. Beta is the probability of making a type 2 error when testing a hypothesis. Type 2 error is failing to detect an association when one exists, or failing to reject the null hypothesis when it is actually false. So you kept the null hypothesis when you should not have kept it. If method X and method Y produced different effects, and it was concluded that they produced the same effects. So this is when we are talking about beta type 2 error. Okay?